Howdy, Dennis Bradford here. Let's think some about being, feeling, and doing better.
Future connections may or may not resemble past connections. Hume undermined belief in the causal principle, as I attempted to explain in the previous video. Anything may cause anything. Look and see what causes what. That's Hume's attitude, and he's right. As you've undoubtedly experienced for yourself, it's impossible to predict future consequences from present acts. We hope and believe that past connections will continue to obtain in the future, and they often do, but that's not necessarily the case. Still, commonly held beliefs resist change. Let's consider physical momentum as an example. Ontological momentum is the topic of the next video. Suppose that you're watching as I push a pen across the surface of a table. Answer quickly. Why is the pen moving? You'd reply, because you're pushing it. That's common sense. Is it, though, true? Aristotle asked, what causes motion? His answer was that moving bodies move because they are pushed. For him, when we observe a moving body, the causal question to ask is, what's now causing it to move? In fact, his physics was grounded on that idea. Basically, for Aristotle, the physical world was a sequence of nested spheres, such that the motions of inner ones were caused by motions of the next outer ones. For example, imagine a wave on the ocean. Unlike animals that have the power of self-motion, it's not causing itself to move. What's causing the motion of the wave? The wave is moving because the air is pushing it. If so, what's causing the air to move? Something greater must be pushing it. And whatever that is, must in turn be pushed by something even greater, and so on. The process ends, according to Aristotle, with the unmoved mover, God, who causes motion by attraction rather than by contact. Do bodies move because they are pushed by other bodies? As natural philosophers in the Middle Ages thought more about this, they realized that there was a problem with respect to projectile motion. Suppose you use a bow to shoot an arrow. As the arrow is flying through the air, what's pushing it? Well, if it's true that things move because they are pushed, then perhaps the air from in front of the arrow is somehow moving around it and pushing on it from behind. That seems absurd because it is absurd. Something is wrong. It took the genius of Isaac Newton, 1642 to 1727, to figure out that Aristotle wasn't asking the right question. If we ask, what causes motion, it's still difficult to come up with any answer that's better than Aristotle's, namely, moving bodies move by being pushed. In effect, with his first law of motion, Newton turned the question around. If a body is at rest or in a uniform motion in a straight line, then it will continue to be at rest or in motion unless an unbalanced force acts on it. In other words, if a body is at rest or moving at a constant speed in a straight line, its velocity will be constant. Therefore, instead of asking, what's causing a moving body to move, ask, what changes the velocity of a moving body? If it's at rest, ask, what changes the zero velocity of a stationary body, or what accelerates it? Newtonian physics replaced Aristotelian physics because answering Newton's question is better and more fruitful than answering Aristotle's question. For one thing, Newton's physics accounts for projectile motion, whereas Aristotle's doesn't. Instead of thinking about what causes motion, Newton taught us to think about what causes changes in motion. Notice that nothing about moving bodies changed at all. Only our understanding changed. For Newton, moving bodies not only have velocity but mass, and momentum comes from those qualities. A moving body's momentum is equal to the product of its mass and velocity. When it's measured, the measurement is relative to the motion of the observer. According to Newton's second law of motion, the time rate of change in momentum is equal to the force acting on the body. In other words, force equals the product of mass and acceleration. According to his third law of motion, for every action there's an equal and opposite reaction. Of course, Einstein came along later and revolutionized physics again, as well as our understanding of space and time. If you want more on that, the most helpful book I've found is Einstein by Walter Isaacson, Edward Herman, et al. In the next video, let's turn from the idea of physical momentum to the idea of ontological momentum.